Here we discuss the tangential and normal components of acceleration. Imagine an object is moving in the space along a curve at any instant t. We know the tangent vector tt, the unit tangent vector tt is given by r dash t divided by modulus of r dash t. And the unit normal vector is the vector perpendicular to this tangent, which is given by t dash t divided by modulus of t dash t, which is called the principal unit normal vector. So first we take a problem of finding the unit tangent vector and the unit normal vector. Let us see the helix defined by rt is equal to 2 cos ti plus 2 sin tj plus tk, t greater than or equal to 0. Here we have to find the unit tangent vectors tt and the unit normal vector nt at any t, and also we have to sketch c, and the vectors we have to calculate at particular instant t is equal to pi by 2 and the n at pi by 2. So let us see how do you find solve this problem. So given rt is equal to 2 cos t I plus 2 sin t j plus t k, dr by dt, differentiating rt with respect to t will get minus 2 sin t I plus 2 cos t j plus k plus, and the unit tangent vector tt is given by dr by dt divided by modulus of dr by dt. Now what is modulus of dr by dt? Modulus of dr by dt is square root of minus 2 sin t square plus 2 cos t square plus, here it is 1, so 1 square, which is equal to square root of, 2 sin t square means 4 sin square t plus 4 cos square t. So you can take 4 outside, 4 into sin square t plus cos square t, and sin square t plus cos square t is 1. So this is only 4 plus 1. So let us write 4 into sin square t plus cos square t plus 1, which is equal to root 4 plus 1, which is equal to root 5. And therefore the unit tangent vector tt is minus 2 sin t I plus 2 cos t j plus k divided by root 5. You can take this, you can write as minus 2 by root 5 sin t I plus 2 by root 5 cos t j plus 1 by root 5 k. Now differentiating this t with respect to t, dt by dt is equal to minus 2 by root 5 derivative of sin t cos t I plus 2 by root 5, this term by cos t, derivative of cos t is minus sin t j plus 0 to 0, and that's equal to minus 2 by root 5, you can take outside, cos t I plus sin t j this dt by dt. And we want to find the unit normal vector nt, which is given by dt by dt divided by modulus of dt by dt. And from this modulus of dt by dt equal to square root of 2 by root 5 cos t square, that is 4 by 5 cos square t plus 4 by 5 sin square t. Again you can take 4 by 5 outside, cos square t plus sin square t is 1, it is only 2 divided by root 5, 4 by root 5 square root of 2 by root 5. And therefore unit normal vector is minus 2 by root 5 into cos t I plus sin t j divided by 2 by root 5. Cancelling 2 by root 5 is reduced to minus of cos t I plus sin t So these are the unit tangent vector and unit normal vector at any instant. And we can find the unit tangent vector at pi by 2 by putting t is equal to pi by 2 in this expression. Here the t of t is equal to minus 2 by root 5 sin t I plus 2 by root 5 cos t j plus 1 by root 5 k. So when you put t is equal to pi by 2, now sin pi by 2 is 1 and cos pi by 2 is 0. So this term is 0. So this is minus 2 by root 5 I plus 1 by root 5 k. So that is actually t at pi by 2. Similarly, you can calculate n at pi by 2 by putting t is equal to pi by 2 here. It is this component is 0, cos pi by 2 is 0 and sin pi by 2. So it is reduced to minus j. And for sketching, what you have to do is, given rt is equal to 2 cos t plus 2 sin t j plus 2t. That means here xt is actually 2 cos t. Yt is, when you write this in the parametric form, you get yt is equal to 2 sin t and zt is equal to t. Now from this you can see that x square plus y square is actually 4. So you get x square plus y square is equal to 4 and zt is t. Z is equal to x square plus y square is equal to 4 is a cylinder. Z is equal to t, when t varies, Z is equal to, we are getting actually it is an helix. So it is a helix surrounding the cylinder like this. It may start like this and it is going like this. So this is the sketching of that. Now we discuss tangential and normal components of acceleration. We imagine an object is moving in space. At any instant t, assume that the object reaches here and it has a velocity or the tangential vector vt, and which is given by v into t, so that we can prove vt, velocity at any instant t is given by v into t, where v is the speed of that velocity. Suppose speed of an object is v at any time t, then we know v is equal to absolute value of the velocity vector vt, and that is absolute value of r dash. So v is equal to modulus of r dash. Speed is given by modulus of r dash, and velocity vector is given by, velocity vector at any instant t is given by dr by dt or r dash. Speed is nothing but modulus of the velocity vector, that is modulus of dr by. Now the unit tangent vector is given by r dash t divided by modulus of r dash t, and therefore the velocity vector Vt is equal to, it is dr by dt or r dash t, and from this expression r dash t you can write as t into, that is unit tangent vector into modulus of r dash t, and modulus of r dash t is the speed, and therefore the velocity vector Vt you can write as v into t. So that is what we have shown here. Velocity vector at any instant t is given by v into t, where v is the speed of that object and t is the unit tangent vector at that point. And we know acceleration A is dv by dt, that is d by dt of v is v into t. The velocity vector v is v means the speed of t. So it's a scalar quantity and this is a vector quantity. This actually put like this, v, and this is without arrow. So d by dt of vt is equal to v dash t into v t dash. When you differentiate v into t, v into derivative of t plus, that is v t dash, plus t into derivative of v, that is t into t dash. So acceleration A is given by v dash t plus v into t dash. Now we are going to express this in terms of normal vector and the tangent vector, that is unit tangent vector and unit normal. Already we got the first term in the in terms of t, but the second term we will express it in the n, normal vector, unit normal vector. We know the unit normal vector is given by t dash divided by modulus of t dash, and therefore t dash is equal to modulus of t dash into n. T dash is equal to modulus of t dash into n. And also we know kappa is given by the curvature at any instant t, kappa is given by modulus of t dash by modulus of r dash, that is dt by dt divided by dr by dt, which implies you can write from this modulus of t dash is given by kappa into modulus of r dash, and modulus of r dash is nothing but the speed v. So you can write a modulus of t dash is equal to kv, and therefore substituting this modulus of t dash is equal to kv, kappa v, here we get t dash is equal to kv into n, kappa into v into n, kappa into v into n. Therefore acceleration A is equal to v dash t. In the place of t dash you write this expression kvn, so you get v dash into t plus v into kv into n, that is v dash t into kv square n. Thus we have got acceleration vector is equal to, in the form at into t plus an into n, where that at is the acceleration along the tangential component, tangential component, and this is actually v dash, this is at, and this is an, that is acceleration along the normal component. Normal component of the acceleration A is kv square, and the tangent component of the acceleration is v dash. So if this is the picture here, acceleration is acting along, this is the tangent, unit tangent vector, and this is the unit normal vector. And this acceleration you can give in terms of, you can write at and an, where at and an are the acceleration component along the tangent vector, and this an is the acceleration along the normal vector. And now we are going to have an expression in terms of r dash t like that, this A. We have already A is equal to at into t plus an into n, and we will prove this acceleration along tangent is given by r dash t dot r double dash t divided by modulus of r dash t, and the normal component of the acceleration n is given by r dash t cross r double dash t divided by modulus of r dash t. So one is the dot product and this one is a cross product. Both are actually scalar quantity. So r dash t into r double dash t is the scalar, and here it is modulus of r dash t into r double dash r dash t cross r double dash t is nothing but it is also a scalar. Now how do we prove? We know v dot a. Let us take v dot a. V dot a is equal to, v is v into t, speed. This is speed, this is tangent vector. So v into t dot v dash t plus kv square. This we have already got, A is equal to vt plus kv square. So by taking dot product, you will get v into v dash into t dot t plus v into kv square, that is kv cube into t dot n. And we know t dot t is mod t square, and t is the unit tangent vector, and therefore mod t is 1. So this is reduced to v dash, whereas t and n are orthogonal, perpendicular to each other, and therefore dot product is 0. So this term is reduced to 0. So finally we get v dot a is reduced to v dash only. So this v dash only. And from this v dash is equal to, we have actually v dot a is equal to v into v dash, and therefore v dash is equal to v dot a divided by v. So that is what we got. V dash is equal to v dot a divided by v, and hence at is equal to, this is at is actually v dash. V dash is v dot a divided by v, and v is r dash t, acceleration is r double dash t. So r dash t dot r double dash t divided by, and this is speed, is modulus of r dash. So we have got at is equal to r dash t dot r double dash t divided by modulus of r dash t. Similarly, an we have found kv square, kappa into v square, and we have already a formula for kappa, which is modulus of r dash t cross r double dash t divided by modulus of r dash t cube into v square is modulus of r dash t square. Cancelling this modulus of r dash t square, we get modulus of r dash t cross r double dash t divided by modulus of r. So we are getting a formula for the acceleration along normal, that is the normal component of acceleration, given by modulus of r dash t cross r double dash t divided by r dash. So in this section you may be asked to find the two components of acceleration, that is along tangent and along normal, and remember this formula, acceleration along tangent vector is given by r dash t dot r double dash t divided by modulus of r dash t, which is the dot product. And acceleration along the normal component an is given by modulus of r dash t cross r double dash t divided by modulus of r dash. Now we will take a problem. A particle moves along a curve described by the vector function rt is equal to ti plus t square j plus t cube k. We have to find the tangential scalar and normal scalar components of acceleration of the particle any time t. So given here rt is equal to position vector at any instant given by ti plus t square j plus t cube k. We want to find the tangential scalar and normal scalar components of acceleration. That is, we have to find at and a. To find at and a, we have the formula at is equal to r dash t dot r double dash t divided by modulus of r dash of. So to get this, we need find the r dash t, r double dash t. We have rt is equal to this, which implies r dash t is equal to, differentiating we get I plus 2tj, derivative of t square is 2t, 2tj plus derivative of t cube is 3t square, 3t square k. And also r double dash t is equal to, again differentiating we get the derivative here, it is 0I, 2t is 2j plus 6t k. And from this we need find the modulus of r dash of t. Modulus of r dash of t is equal to square root of 1 square plus 2t square, that is 4t square, plus 3t square square, that is 9t raised to 4. So we have got all r dash t, r double dash t, and also modulus of r dash t. So substituting here we will get et. R dash t dot r double dash t. R dash t is I plus, so it is I plus 2t j plus 3t square k dot r double dash t, that is 0 I plus 2j plus 6t divided by modulus of r dash of t, that is square root of 1 plus 4t square plus 9t raised to 4. So calculating this, taking the dot product, we get there is 1 here, 1 into 0, 0 I. So you are getting 0 I, 2t into 2, 4 plus 4t j, then 3t square into 6t, 18 t cube k divided by square root of 1 plus 4t square plus 9t raised to 4. So this is acceleration along tangent component, tangent vector, or we can say the tangential component of acceleration. Now we will find the normal component of acceleration. An is given by modulus of r dash t cross r double dash t divided by modulus of r dash of. So already we have got modulus of r dash t, so we need to find the cross product of r dash and r double dash. Here modulus of, first we find r dash t. Here r dash t cross r double dash t, it is written as a determinant I, j, k, and the ith component here it is r dash t is 1, 2t, 3t square, and that of r double dash t is 0, there is no I here, so 0, 2, 60. Now expanding this, we will get r dash t cross r double dash, that vector we will get. So when you expand this determinant, you will get this vector in the form 6t square t square I minus 6tj then plus 2t, this vector, and therefore the acceleration along the normal component or normal component of the acceleration given by modulus of this vector, that is square root of 6t square the whole square plus minus 6t the whole square plus 2 square divided by modulus of r dash, which is square root of 1 plus 4t square plus 9t raised to 4. And this you can write as, you can take 4 outside if you want, or you write as it is square root of 6 square 36 t raised to 4, then plus 36t square plus 4 divided by square root of 9t raised to 4 plus 4t square plus 1. This is the normal component of the acceleration. This problem you can try. This is the motion of a projectile given by the formula Rt is equal to 250 root 3t I plus 100 plus 250 t minus 4.9 t square j. Here we have to find the tangential and normal components of acceleration. Here we are given Rt is equal to 250 root 3 pi plus etc. It's actually in the plane. Here RT is equal to 250 into root 3 into T into I plus 100 plus 250T minus 4.9 T square. See, find R dash T, R double dash T and also modulus of R dash T. So these are the things we require to calculate AN and AT. AN is given by modulus of R dash T cross R double dash T divided by modulus of R dash T, and the AT, the tangent vector acceleration along the tangent, is given by R dash T dot R double dash T divided by modulus of R dash T. So this you can find. Here it is given, RT is given, so differentiating will get R dash T, R double dash T, and also find the modulus of R dash T and substitute here, and the cross product always, if A is equal to A1I plus A2J plus A3K, and similarly vector B is equal to B1I plus B2J plus B3K, then the cross product of the two vectors A cross A and B is given by determinant Ijk A1, A2, A3, B1, B2, B3. So just using this formula you can calculate R dash T cross R double dash and take the modulus, will get modulus and divide by modulus of R dash T. So this you can try, finish it. And in the second B part it is given, or it is asked to find the AT at T is equal to 0. So we will get AT as an expression in terms of T, and put T equal to 0, we will get AT. Similarly, A and T you can calculate. Is the shell accelerating or decelerating in the tangential direction at the values specified in part B? So this is actually, you calculate AT at when T is equal to 0, T is equal to 12.75, T is equal to 25.5, T is equal to 38 point. So these, at each of these points you calculate AT. When T is equal to 0 you calculate AT, when T is equal to 2.75 you calculate like that, you get all ATs. Now if this AT is increasing, you can say this accelerating, or if it is diminishing, you can say it is decelerating. Which one? In the tangential direction, that means A. In the tangential direction we are doing. So calculate AT at T equal to 0, T equal to 12.75, T equal to 25.5, T equal to 38.25, and if these values are increasing, you can say it is accelerating, and if it is decreasing, we say that's decelerating. So this is how we comment this, answer this question. Is the shell accelerating or decelerating? Okay. So with this, I stop the video. I think this video will help you to know about the tangential and normal components of acceleration. Thank you.